Greetings, colleagues. After exhausting my interest in trading futures, I decided it was time for something new. Cryptocurrencies are currently trending, and the highlight of this crypto season is Pumpfun. Pumpfun has its own API, so it's time to figure out what trading on Pumpfun is and how it works. To start, we need a budget on the Solana network. Spoiler alert, I had to top it up 4 times, but let's see how things turned out. I ran everything locally on Windows using Node.js. Before launching my bot, I had zero knowledge of Node.js, with only ChatGPT at hand. Process and strategies. 1. Token creation strategy. The first strategy everyone tries on the platform is creating their own token, hoping it will stand out and multiply their investments 10-fold, 100-fold, or even 1,000-fold. The API allows automatic token creation. Most tokens are essentially scams, and most participants in the trades are bots. Each token cost me about $7 to create. None of them appreciated in value. Tokens can have an initial buyback value set or left unset. I set the first token's buyback at 0.5 SOL, and this was the only token that, so to speak, gave a profit of $5. It was quickly bought and then quickly sold. All subsequent tokens brought no profit and simply consumed the creation fee. My hypothesis as to why the first token gained traction is that it was the first one and had a relatively low initial buyback of 0.5 SOL. Later, I tried creating tokens under different public keys, but they didn't attract any activity. Conclusion: without a token sales strategy, creating tokens is pointless. 2. Bot strategy, identifying viable tokens. Remember, 99.9% of tokens are scam tokens traded solely by bots. The average lifespan of most tokens is less than 5 minutes. I discovered this only later. The first hypothesis for my bot was to identify tokens with potential longevity, those that survive for more than 4 minutes. I set up an additional process to monitor transactions for these tokens. Each transaction either added or removed token holders. After 2 minutes, the bot would check how the token was performing. If it had gained more than 15 holders, the bot would buy the token. Using mechanisms from Web3.js and other libraries ChatGPT suggested, I managed to implement the SendPortal transaction function to handle token purchases and sales. Initial selling strategy. The first approach was to sell the token when the developer's tokens were also being sold. However, it quickly became apparent this was unworkable, as developers didn't always have tokens to sell. The bot could end up holding a token indefinitely, depleting the overall budget. 3. Observing King of the Hill tokens. Tokens labeled as King of the Hill by Pumpfun were often sold at 90 to 100% bonding curve progress. Thus, my second selling signal became selling at 91% progress. When a token reaches 100% on the bonding curve, it transitions to the Radium platform, temporarily blocking token purchases and sales. My assumption was that Pumpfun's buy-sell API might not work during this transition, but I haven't verified this yet. 4. Adding developer parameters. To further refine the bot, I introduced 2 parameters. The Solana balance of the token's developer. Whether the developer had created other tokens before. I stored new tokens in a MongoDB database, a new experience for me. For those unfamiliar, MongoDB is a NoSQL database where tables are called collections, and data entries are documents. Collections can be created with the first document insert. By analyzing the first 100 tokens added to the database and checking whether developers had created other tokens, I realized this was a common practice. Developers often created multiple tokens, which became another filtering criterion. However, I concluded that this factor doesn't significantly impact the bot's effectiveness, as 99.9% of tokens are scams regardless. 5. Analyzing initial buybacks. Another hypothesis was that developers who buy back more than 10% of the total token pool during creation might have plans for a legitimate project. This turned out to be false. 6. Social media and websites. At one point, I focused on whether tokens had associated social media accounts or websites. It seemed logical that tokens with well-designed websites or active social media pages might indicate a legitimate project. However, this turned out to be a flawed assumption. Even tokens with professional-looking websites and seemingly promising ideas often turned out to be scams. This reinforced the notion that appearances can be deceptive, especially in such a high-risk environment. Moreover, Pumpfun's API doesn't provide this kind of information directly. Analyzing these details manually would only be relevant for tokens with significant market capitalization, typically ranging between $300,000 and $600,000. For projects of this scale, a developer might actually intend to pursue a long-term plan, but these cases are exceedingly rare. In summary, while this information could be conditionally useful for evaluating larger projects, it's largely irrelevant for smaller tokens, which dominate the Pumpfun ecosystem. 7. Identifying patterns. At this stage, I started searching for new parameters to build hypotheses and identify patterns that could lead to profitable strategies. Two notable parameters emerged. The number of consecutive buys. The number of consecutive sells. These parameters were based on observations of tokens that exhibited a series of consecutive purchases. The hypothesis was that inserting the bots by orders within such a streak of purchases could allow it to sell quickly at a small profit. For example, tokens that demonstrate a consistent increase in activity often attract more bots or human traders, creating a temporary price pump. The strategy was to ride this wave and exit before the inevitable crash. Although this approach didn't guarantee massive profits, it was the only consistently working strategy for trading bots on Pumpfun. 8. Refining the bot strategies. Monitoring token sales for better purchases. My strategy of checking the bot every 2 minutes turned out to be inefficient and inflexible, so I had to abandon it. At this stage, I also struggled to understand why the token purchase cost was approximately 50 cents higher than the amount I specified in the request. After investigating through Solscan, I discovered this was due to a Pumpfun platform fee called Create Account, which is charged for creating and confirming a new token under my public key. When testing token purchases with a budget of $3 to $5, this fee often consumed potential profits. Therefore, I concluded that a trading bot like mine should operate with transaction amounts of at least $20. Consequently, I focused on ensuring that the bot could trade at such volumes to gradually increase the amount allocated for purchasing new tokens. 9. Competing with other bots, a PvP battle. Challenges of pattern detection in a competitive space. Finding patterns is a challenge and feels like a PvP battle with other developers. It's not uncommon for a developer's bot, using dozens of different wallets, to highlight a token for other bots in the same second and then execute an instant sell-off of all tokens across their public keys within 10 seconds. This is one of the strategies used by token creators. In theory, I could experiment with this token creation game in the future, but I feel that such a strategy could carry potential legal implications. 10. Identifying fake wallets and transaction patterns. How token creators use fake wallets to simulate activity. With fake wallets belonging to token creators, initial purchases often occur in evenly distributed transactions, which can be a factor for tracking. These bots make it difficult or even problematic to configure your own bot based on, for example, the sequence of positive transactions. Such sequences would typically indicate genuine interest, but these fake wallets generally only serve to highlight the token for other bots, creating the illusion of token activity. 11. Current bot performance and strategy refinement. Experimenting with scenarios. Currently, my bot is trading around break-even. I'm experimenting with different scenarios to refine its performance. After testing various parameters, I've developed the following strategy for purchases. Checking for initial sales. The bot evaluates whether the token has already been sold. Some bots immediately start selling after the first sale. Here's an example of such a bot. It works. Whether it actually generates profit is hard to assess, but it does register sales at up to twice the nominal value. Liquidity analysis using VSOL-in bonding curve. The bot considers tokens where the VSOL-in bonding curve exceeds a certain percentage of the initial value, indicating the token has some liquidity. Avoiding tokens on a downward trend. Tokens with a maximum VSOL-in bonding curve above a specified threshold are avoided to filter out those already declining. Holder-to-liquidity ratios. Various ratios between the number of holders and the current VSOL-in bonding curve are analyzed to gauge token activity. Consecutive transactions. Patterns of consecutive purchases and sales are monitored to identify potentially profitable opportunities. 12. Selling strategy parameters. When selling, the bot evaluates several factors. Checking token ownership. The bot first determines if it already holds the token. Holder-influenced coefficients. A coefficient is calculated based on the number of holders and its effect on VSOL-in bonding curve to determine the optimal selling point. Consecutive sales monitoring. The bot observes streaks of consecutive sales to avoid panic selling during temporary declines. Active purchase streaks. If there are ongoing active purchases, the bot delays selling to capitalize on increasing demand. VSOL-in bonding curve at purchase time. The initial value of VSOL-in bonding curve during purchase is used as a reference point to decide the selling strategy. 13. Challenges faced during bot development. Blockchain errors. The primary issues encountered during token buying and selling were: block hash not found, insufficient funds, incorrect program ID. These errors are especially critical during token sales, as your position's value can drop to zero within seconds. Investigating these issues revealed that the process is inherently imperfect, requiring mechanisms to avoid sending duplicate requests. Within a single second, dozens of transactions can be generated for tracking, but the blockchain might take time to process the signature. For example, the block hash not found error occurs when a valid block hash is created but isn't yet ready for signing, as there is an operational delay before the Pumpfun server can accept it. Sometimes the signing process completes within fractions of a second, while at other times, it takes up to a full second. By setting a 0.9-second interval between obtaining the block hash and signing, the script achieves stability, though not 100%. Additionally, if too many requests are made, Pumpfun may return an error asking to retry later with a timeout, potentially causing your position to zero out. Although the script implements a throttle transaction function to prevent duplicate requests within a second, some duplicates still slip through, incurring additional fees. Delaying a sale request by more than 1 second, however, can be fatal to the token's value. The importance of slippage settings. Slippage is a critical parameter, defining the percentage by which a transaction is accepted if the price changes between the request and its execution. Occasionally, this happens, and the blockchain might return the incorrect program ID error. The exact cause can usually be identified in the Solscan interface. While this error might be retrievable via a script, I haven't delved into it yet since it is strategy dependent and can generally be avoided with proper slippage settings. Priority fees for transaction success. Priority fees, priority fee, indicate how critical your transaction is to the blockchain and help ensure your signature competes with others. The minimum fee is less than a cent, but Solscan logs reveal that some users send transactions with priority fees of several dollars. Wallets like Phantom typically charge around 20 cents. For my bot, a balance of 10 cents proved sufficient, but this parameter can be adjusted depending on the buy-sell strategy. Resource limitations and WebSocket closures. Monitoring a large number of keys increases resource usage. With over 80 transactions, my WebSocket connection would often close, likely due to a limit on the number of tokens analyzed simultaneously. To mitigate this, I implemented mechanisms to remove tokens from transaction tracking, including disabling tokens with no activity for a specific period. Initially, Tokens inactive for 5 minutes were removed, later reduced to 2 minutes, and eventually to just 1 minute. The pace of activity on Pumpfun is that fast. Issues with the BIP39 library. The BIP39 library failed to correctly match public and private key pairs derived from mnemonic phrases. As a result, I switched to implementation based on private keys instead. RPC node misconceptions. At one point, I assumed that using services like QuickNode, Alchemy, or Helios would improve request stability. This turned out to be a mistake because requests to Pumpfun directly interact with its server, while the RPC node is only used to fetch public key balances, a parameter that isn't particularly useful for the bot. Interestingly, even users with over 100 SOL in their accounts often create scam tokens. Residual tokens and holder count. When selling tokens, Pumpfun sometimes leaves one token in a holder's account, which doesn't reduce the holder count. At one point, I added a check to exclude holders with fewer than 100 tokens from being counted, but I later removed this as it was not critical to the bot's operation. Future plans and potential experiments. Analyzing tokens for global trends. In the future, I'd like to focus on analyzing tokens with a large supply to identify global trends. This could potentially lead to profitable trading opportunities on platforms like Radium. By understanding broader patterns, I could target tokens that show long-term viability instead of fleeting activity. Experimenting with token highlighting and price manipulation. Another potential direction is experimenting with mechanisms to highlight tokens for other bots, artificially boosting visibility in price. While this aligns with some Pumpfun strategies, my ultimate goal would be to explore this in the context of creating legitimate Web3 projects. After all, Pumpfun provides a direct pathway to real money, bypassing traditional exchanges and financial institutions. Reflecting on the experience. This project gave me a significant emotional boost, satisfied my thirst for risk and excitement, and allowed me to master several new technologies while sparking fresh ideas. I hope you found this video helpful. If there's interest, I might publish the script as is, with open source code, on my website for purchase. Check the description for the link or feel free to reach out directly. But remember, doing your own research is key,